Okay, question was asked about problem number 19 in 1.1, and the directions are a little bit confusing right here. It says to describe the set as a union of finite or infinite intervals. What they're basically asking you to do is solve this absolute value inequality, graph it if need be, and then write the answer as one or more intervals being put together. So we talked in class in our notes in 1.1 about how to handle a problem like this. I'm actually going to deal with this one graphically, and I'm hoping this makes some sense then if we went through that together. So what we are essentially dealing with right here, guys, is a statement that says the absolute value of x minus 4 is greater than 2. What this really means here is they are asking us to describe the distance between a number and 4, and we want that distance to be greater than or equal to 2. So if I was approaching this graphically, the number right in the middle of my graph is going to be my h value, if you want to look at it that way, and that's going to be a positive 4. The number that is being subtracted from x is what goes there. Then what we're going to do is we're going to let this number here, which in this case is 2, represent the distance between this h value and then the 2 points on our graph. So if I were to go 2 units to the left of 4, that's going to get me to 2, and 2 units to the right of 4 is going to get me to 6. Now I'm going to switch my pen over to blue right here. We are dealing with open dots now because our inequality symbol is just greater than, not greater than or equal to. So we're going to do an open dot here at 2 and an open dot here at 6. And what we want now is to shade all of the points whose distance from 4 is more than, greater than 2. So that tells me, at least my hunch anyway, is that I'm shading way out here to the left of 2 and way out here to the right of 6. Now, one of the important things I want you guys to get good at here is recognizing that it's pretty easy to test your answer to find out if it's right. If I were to pick a number over here that is in my shaded region, like -1, I'm just guessing, -1 is shaded, meaning that it should give me a true statement when I plug it into the original statement right here. So let's try it. -1 minus 4 is -5. Whose absolute value is 5, and 5 is greater than 2. Yes, it is. So this statement works here, meaning -1 is a solution, and it should be shaded, which it is. I could pick a number way over here in the shaded region on the right to test. So maybe I'm going to pick a weird number like 17. This should give me a true statement as well. 17 minus 4 is 13. Absolute value is 13, and 13 is greater than 2. So I feel good about this answer. Just for fun then, how about I pick a number right here that's not shaded, like 5? Now, because 5 is not shaded, that should give me a false statement when I put it in. Let's try it. 5 minus 4 is 1, whose absolute value is 1, and 1 is not greater than 2. I was expecting a false statement there, and I got it. Okay, so my graph was solid then, it would certainly appear, so I feel good about that. And if the direction said, hey, graph this thing, then we'd be all set. But they say describe the set as a union of finite or infinite intervals. They want the answer in interval notation. So this interval right here, guys, the one that I shaded on the left, doesn't begin anywhere, so we would say it starts at -infinity and ends at 2. It's always going to be a parenthesis on an infinity or a -infinity. And in this case, because that 2 has an open dot, that's going to be a parenthesis there as well. If we had a closed dot right here, which would have been because it was greater than or equal to, then that would have been a bracket. But that is not the case in this problem. Then we have a second interval over here that starts at 6, never ends, so we put an infinity there. These are going to be parentheses on both sides as well. And this graph, pretty much every time you see 2 dots and then shaded to the outside, is going to be an OR graph, meaning it's going to be a union of these 2 intervals. So our solution then is any number that is between -infinity and 2, or between 6 and +infinity. So that is the answer that they are looking for here and the format they wanted on problem number 19.